My goal in this video is to give you a sense for just a quick introduction to vectors, like what a vector is, how we work with them, and just a few basic things. So first of all, what is a vector? A vector is a mathematical object that expresses distance and direction. Sometimes they'll say magnitude and direction, but distance and direction are the two big things. There are really three different ways to represent vectors that you need to be aware of. My favorite of them is as a column vector, which means you sort of draw, it actually looks a little bit like a matrix. You draw sort of a vertical matrix, right? So the vector 3, -5 written in a column like that is one way to represent vectors. Another way is to use angled brackets, which is sort of like a point, but instead of using parentheses, you use sort of angled brackets. So these two things are the exact same vector. They're just different ways of writing it. One other way is using the ijk notation, where you'll put 3i minus 5j. And, if there was a z-coordinate, if there had been a 1 here and a 1 at the end, then you'd have, plus 1k here at the end. So the idea is we have column vector form, we have angle bracket form, and we have, this is sometimes called unit vector form. All different ways of representing vectors. All three of these are the same vector, right? And all three of them represent this concept of going 3 to the right and 5 down. Right? Based on our Cartesian system, we understand 3, -5 to be to the right 3, down 5, and so that is our vector. Remember, a vector is supposed to represent distance and direction. And so this vector is effectively saying go that far in that direction, right? So that's what a vector is. Okay? For the remainder of this video, I want to talk about how we create vectors, and there's sort of two different ways to do that. The first of which is talking about a position vector. So position vector is one of the most common ways that this shows up on the exam. A position vector is basically any vector that's pointing from the origin to a particular point. And the easiest way to create a vector in any way is to make the position vector. That position vector would be called OA. You'd usually put a little arrow over the top of it. So if you wanted to make the vector OA from the point A, all it means is you sort of take the point and write it in vector form, right? So, if somebody asked for the position vector OA of the point 2, -7, 4, you just write 2, -7, 4. Right? That makes sense. On the previous page, when we talked about the example of the vector 3, -5, when I graphed 3, -5, I did this. If I had just put a point there, that would have been the point 3, -5. When I drew the arrow to the point, okay, now that arrow is the vector, right? So there's a slight difference between a point and a vector. A point is sort of where you get to. The vector is this direction, that length. It's that concept, okay? So one of the easiest ways that you'll create a vector on an exam is they'll ask you to make a position vector, and literally all it means is write that point as a column vector, or write it as an angle bracket vector, or write it, 2i minus 7j plus 4k. Any one of these three things would have been acceptable answers for this question. Okay? The other way to make a vector, and this formula is like staring at you, I made it huge because it's important. This is probably the most important formula in vectors. There's some other big ones, but this is a very, very basic one. Not all vectors are position vectors. Not all vectors start at the origin and go to a point. Some vectors will go between 2 points. So for instance, the vector AB, AB with a vector mark over it, AB is the vector that starts at A and goes to point B. So if you've got, a point A here and a point B here, that is the vector AB, right? How do we find vector AB? Well, I've got a formula right here. It says that vector AB is equal to vector OB minus vector OA. In other words, if you take the the end point, and start with that position vector, and then subtract off the initial point, the OA, it'll get you the vector between them. And I'm not going to dwell on this for too long, but I did want to give you some sense for why that happens. And the best way to see it is to think about a rearrangement of this formula. What if I were to add OA to both sides? I would end up with OA plus AB equals OB, right? And I sort of want to use this diagram above to illustrate that. Imagine if someone told you directions to go from O to A, right? like you're on a scavenger hunt or something. So they say, yeah, here you go from O to A. Great. And then once you get there, you get your new instructions. You did this, plus, then they told you to go from A to B. Now you get here. At that point, you might ask them, you know, why didn't I just go from O to B? In terms of the end product, if I follow OA and then follow AB, aren't I just going to get from O to B? Like, I understand they're different directions, but both of them result in the same thing. So the idea is, I mean, if you're willing to buy this idea, it should not be a stretch for you to sort of rearrange, to move the OA to the other side, and get this as sort of the formula for how we create the vector between 2 points. And like that formula right there, that will be worth at least 2 points to you on the IB exam somewhere. To be honest, that right there is probably going to be the first 2 points in more than one vector question on the IB exam. So it's incredibly valuable that you know that formula and use it. So I have one quick example of that. I'm going to give you these 2 points, A and B. I want you to write down first the position vectors OA and OB, and then find the vectors AB and also BA using the formula that we just talked about. So pause the video, take a minute to do that, and make sure you've got this basic idea before we finish out this video. So for part A, the vector OA, I mean, this should be like laughably simple. OA is negative 1, 5. Again, my favorite is column vectors, so I'm going to use column vectors. The position vector for OB just means I write the point OB as a column vector, and there we go, we win. For part B, if you want vector AB, well, the formula says do OB minus OA, which means I'm going to do 3, negative 2 minus negative 1, 5. And this is something I haven't covered in these videos yet, but I hope it's clear. If you have one vector minus another one, you just subtract the components. So for this, I'll do 3 minus negative 1 and get 4 for the x-coordinate. Then I'll do negative 2 minus 5, so that's negative 7 for the y-coordinate, and that is vector AB. Okay. If we want vector BA, we could do by doing OA minus OB. That would certainly work. But the other option is think about what BA is. BA is just the AB vector going in the other direction. So we could just take the opposite of the AB vector. Right? Like if I just take the answer that I just got up here and just do the opposite of that, I should be able to find that vector BA is negative 4, positive 7, and that is the other non-position vector that we can find. So the 2 big things to take out of this video. First, that a position vector is just a vector that points from the origin to a point. And the second thing is that we have this formula. This formula allows you to find the vector between any 2 points. I suppose the last thing I would say, it's not always going to be A and B. If they ask you, oh, we want you to find vector XV, okay, it's OV minus OX. Right? It's always the end coordinate as a vector minus the initial coordinate as a vector. If you go with that, you will not have trouble writing vectors.